In continuation to the earlier session, we are going to continue with the ammoxidation. Ammoxidation is the part of organic named reactions. This is a content retrieved from textbook of organic named reactions, which is written by Dr. Kavitha Kotthireddy Kota. The series of sessions which you want to retrieve regarding these organic named reactions all are available at the channel called World of Competitive Chemistry. Let me go with the ammoxidation process. Ammoxidation is a gas phase oxidation process that introduces nitrile group, C triple bond N, into organic molecule by reacting with ammonia, oxygen, typically in the presence of metal oxide catalyst. Industrial grade scale production of acetonitrile synthesis is taken by ammoxidation process. So here propane, oxygen and ammonia taken as a starting materials in order to accomplish this acetonitrile as the final product. Here propane, one of the component added with the stoichiometric ratio of oxygen and ammonia taken over there. Oxidation in the presence of ammonia, you can simply say ammoxidation. So that you can accomplish carbon, 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 3 carbons with the nitrogen atom with the nitrile functionality, and in addition, water formation is possible. This is the way ammoxidation process is accomplished. When we are taking a kind of molecule with the furan and aldehyde functionality at the position number 2 and 5, and the same oxygen is applied over there and ammonia is added in the stoichiometric ratio. So here manganese oxide added as a catalytic conditions, and the acetonitrile is the solid media. Reaction operated at 60 degrees centigrade for the period of 3 hours. There is a formation. The whatever aldehyde is there that turned into a nitrile functionality, one provision, and both the alcohols will be transformed into nitriles in the second case. But here, being the stoichiometric ratio is more susceptible for mononitrile formation instead of dinitrile. So that's the reason why compound number 1 yielded in 92%. So this is the way kind of ammoxidation process is accomplished. This is the industrial way of synthesis. In this ammoxidation process, it is accompanied by catalytic oxidation, ammonia taken as a catalytic conditions. Main functional group over here will be nitrile. Origination of nitrile taking place within the reaction mixture. Conditions: high temperature, you need to perform 300 to 500. If a catalyst is applied, temperature is sufficient at a slightly higher than the room temperature. Metal oxide taken as a catalyst over there, and the phase, gas phase, being a 300 to 500 is able to provide gas phase molecules, so that vapor phase reaction is suitable for this ammoxidation process. If you want to observe about the mechanism of the reaction, activation of alkyl group is step number 1, and formation of imine intermediate taking place. Further oxidation, nitrile product formation is possible. Water is obtained as a byproduct. In order to achieve this one here, you can notice the kind of biphenyl molecule that methyl substitution is there, ammoxidation carried, giving rise to methyl turned into a nitrile, and moreover again ammoxidation giving rise to dinitrile formation, right? Whenever dinitrile formation is taking place, you can mention this compound. You can mention this compound as a cyclic one, being it is oxidized further, and cyclization taking place, so that here the formation of cyclic amide will be noticed. Whenever cyclic amide formed as a intermediate compound, that further subjected to a kind of ring opening hydrolysis, and followed by dehydration process, giving rise to mononitrile as the final product. So biphenyl carbonitrile formation is possible. This entire process is mean for the ammoxidation, right? Here, the versatile catalyst for ammoxidation will be manganese oxide, or else vanadium oxide can be taken, bismuth molybdenum oxide, strontium iron oxide, all kind of mixed oxides to be taken, so that the reaction is accomplished. If you are taking pyrazine, if the nitrogens are located at 1,4 positions within the 6-membered ring system, that is said to be pyrazine. Here, methylation is there at the position number 2. Methyl pyrazine is taken. oxygen and ammonia. If treated upon this molecule, there is a formation of nitrile at the position number 2. So here, this is the way a kind of product will be originated, or else the entire decarboxylation giving rise to simple pyrazine, and another byproduct formed over here, that is C double bond O NH2. This entire nitrile is transformed into further hydration of this one, giving rise to amide functionality, which is called pyrazinamide. So this is the way mixture of products you can obtain by means of this ammoxidation process of methyl pyrazine starting material. And the same reaction is extended to a kind of toluene with dichloro derivatives at second and fifth positions, and ammonia. 1.5 stoichiometric oxygen is also added. Vanadium oxide taken as a catalytic condition, and thermolytic conditions operated over there. Simply methyl transformed into a kind of nitrile. In addition, water is a byproduct you can accomplish. So this is the way kind of ammoxidation. Simply methyl is transformed into nitrile functionality. Let me explore the applicability of the compound examples pertaining to ammoxidation process. Here we have a methyl functional group over the position number 3. 3-methylpyridine was taken and treated with ammonia, hydrogen, and air conditions are operated. 350 degrees centigrade higher temperature is required, being pyrolytic conditions will facilitate the gas phase ammoxidation process. 60 millipascal of pressure applied over there, so that here wherever methyl is there, simply turned into a nitrile. Subsequent alkaline hydrolysis is giving rise to a kind of amide compound. So that nicotinamide, this is expected product in a alkaloid chemistry. This is the way a kind of transformation you can accomplish by means of ammoxidation procedure. Let me go for the application purview regarding this ammoxidation. Applications of ammoxidation, acrylic fibers are manufactured in the industrial process. Bulk scale synthesis is possible by means of this ammoxidation. Acrylic fibers indicated as acryl nitrile, critical commodity, chemical used to produce the variety of industrial polymers. They may be carbon fibers may be taken, real carbon reinforced plastics may be taken, reclaimed carbon fibers may be taken, and that kind of various carbon reinforced plastic generation you can notice over there. Here carbon fibers, plastics, etc. generated currently. 90% of global acrylonitrile production is based on propylene ammoxidation. Propylene ammoxidation is giving rise to this kind of product formation. ABS plastic, acrylonitrile butadiene systems, chemical formula C8H8 taken in times, C4H6 taken in times, C3H3N taken in times, is a common thermoplastic polymer. So thermoplastic polymer which is accomplished by ammoxidation process only, and glass transition temperature operated 221 Fahrenheit, that is exactly 105 degrees centigrade. This AB is simply amorphous in nature. It is a powdery form of material solid, and so that the sharp melting point will not be accorded for this compound. So here ABS is a terpolymer made by polymerization of styrene with acrylonitrile in the presence of polybutadiene. This is the way ABS plastic will be generated. Synthetic rubbers. In butyl rubber, synthetic rubber is a typical example of acrylonitrile polymeric applications, right? So synthetic rubbers also manufactured by ammoxidation process. Even benzonitrile production from the toluene. If you are taking toluene treated with ammonia and oxygen together, simply methyl is turned into a nitrile by the water as a byproduct. So here, thalonitrile synthesis. If you are taking this, xylene, we can say, orthoxylene to be treated with ammonia and 3 moles of oxygen to be added in the stoichiometric ratio, so that here wherever methyl groups are present, simply they transform into nitrile functionalities and releasing 6 water molecules. Large scale nitrile production wherever required, especially in the polymer industry and manufacturing of coloring agents like dyes and pharmaceuticals and pesticides. Everywhere there is a application of this ammoxidation process. Hence, we can say ammoxidation is most versatile field of applicability, and these many reactions discussed regarding this ammoxidation process. Hopefully, the session is very informative. whatever conceptual chemistry you are looking for, or else a bit point of view of the chemistry for examination purview, everything is available at the channel called World of Competitive Chemistry. This is very convenient for academicians and also researchers. If you go through this channel, you will get the informative sessions over there. Thank you very much for your patient listening.